Hey guys, in this video, I'm not gonna share easy and simple questions. Instead, I'll be telling real and tricky interview question and answers for the experienced people. And trust me, 99% questions from collection framework will come from this video, and you have to just like, subscribe, and watch this video till the end. So now let's get started. First question is, why doesn't collection framework have a common interface for both list and map? So this is very important question. So the Java collection framework is organized like a tree structure with interfaces at the top and classes below them that implement those interfaces. There are majorly two interfaces branches. First is collection interface branch that contain list, set, and queue. Second is map interface branch that contain all kind of maps. It doesn't have one interface because they store and handle data in completely different ways. A list store elements as a single collection of values and work with indexes, but a map stores data as a key value pairs where each value is linked to a unique key. Since their structure, behavior, and methods are very different, one common interface would not make sense. It would either be too generic or confusing. Okay. What problem would arise if collections allowed primitive types? So this is also a tricky question. Collections in Java work with objects, not raw values. They use features like generics, inheritance, and methods that only apply to the objects. Primitive types don't support these, so they wouldn't fit into the collection designs. Okay. Can you design your own collection, and what methods are mandatory? So this is very tricky question. So yes, we can design our own collection in Java. We can do this by either implementing the collection interface or extending an existing class like abstract list, abstract set, etc. If we implement list, we must define get and set methods, right? And if we implement map, we must define put, get, or remove methods. Okay. What is equal and hash code contract? So guys, this is very important, most common question. Actually, this is a rule in Java that keeps objects comparison and hashing in collections. Equal is used to check if two objects are logically equal, means same data, whereas hash code returns a number that represents the object for fast searching and decide bucket. Okay. And the rules says that if two objects are equal using equal method, their hash code must be the same. If two objects have the same hash code, they may or may not be the equal. If we override equal method, we must also override the hash code method. During one execution, hash code method should return the same value unless object data changes. Okay. What happens if equal method is overridden but hash code is not? So this is very important question. If we override equals method but do not override hash code, so equals may say two objects are equal but their hash code will be different, so they will be stored in a different buckets. Okay. And because of this, duplicate objects may get stored in the hash map, or searching in hash map may fail even if the object is logically equal. Can two unequal objects have the same hash code? Yes, two unequal objects can have the same hash code. Hash code is just a number used to quickly group objects and locate the bucket. Since many objects exist but the number range is limited, sometimes different objects may produce the same hash value, and this is called a hash collision. Hey guys, before moving to the next questions, I would like to share one important thing with you. Actually, we have a complete interview preparation material structured step by step by myself, expert, and MNC's interviewers. And the best part is that now no one need to go anywhere else to prepare interviews. There is a 99% chance that interviewers will ask questions from this material. You can check the reviews as well. So basically, it contains a lot of material categorized by experience level, means each experience level has different material with all possible interview question and answers for Java, Spring Framework, Maven, Git, Spring Boot, Spring Security, Spring Data JPA, Kafka, microservices, Java coding questions, Stream API coding questions, and many more. I have provided the link to get this in the below description. And if someone needs this material plus two real enterprise client projects for the reference, plus one-on-one lifetime doubt sessions and referrals to the big MNCs, then they should check the interview preparation kit. I will provide the link for this as well. So now moving to our questions. What breaks if mutable fields are used in hash code? So guys, if mutable or changeable fields are used in hash code, it can break how hash based collisions like hashmap and hashset work. What happens is, an object is added to a collection, its hash code is calculated based on its fields. Later one of those field changes, so now the hash code also changes. Now let's discuss the problem. The object was stored in one bucket using the old hash code. After change, Java searches using the new hash code and it cannot find the object anymore even though it exists. What happens if we modify a list while iterating using for each loop? If we modify a list while iterating it using a for each loop, Java will usually throw a concurrent modification exception. Next question is explain the internal working of array list, and this is very important question. An array list works like a dynamic array. Internally, it uses a normal array to store elements, but it can grow automatically when more items are added. So now let's understand step by step. First step is stores data in an array. Inside array list, there is an internal array where elements are stored in order. Second is initial capacity. When created, it has default capacity, usually 10. Third is adding elements. When we add items, they are placed in the next free index of the array. Fourth is resizing. If the array becomes full, a new bigger array is created. Old elements are copied into it and then new elements is added. New size now becomes 1.5 times to the old size. Fifth is accessing elements. It's fast because it uses index, array based. Time complexity is O1. Sixth is removing elements. That is very slow because elements must shift left after removal. Time complexity is O1. So that's a internal working of array list. Next question is, can array list store null multiple times? Yes, array list can store null multiple times. Since null is treated like a normal element, we can add it many times and it will store each one at a different position. Okay. Next is, why is linked list slower for search operations? Linked list is slower for search operations because it does not use indexing like an array. In linked list, elements are connected using nodes. Each node points to the next. To find an element, Java must start from the first node and move one by one until it reaches the target. Okay. What are the use cases of array list and linked list? We could use array list when we need fast reading searching by index, more read operations than insert delete, storing data in order and accessing it frequently. We could use linked list when we need frequent insertion and deletion, adding removing elements from the beginning or middle, queue or stack type operations. Okay. Next question is how to make our collections thread safe. So this is very important question. We could use collections.synchronize list, collections.synchronize set, and collections.synchronize map to make our collections thread safe. Next question is which one is the best option, using HashMap inside collections.synchronized map or concurrent HashMap? So this is very tricky question. In most real world cases, concurrent HashMap is the better option because collections.synchronized map locks the entire map when one thread uses it. Other thread must wait slower when many threads are waiting, whereas concurrent HashMap allows multiple threads to work at the same time. It locks only a small part internally, not the whole map. That's why concurrent HashMap is better option. How does set ensures uniqueness without knowing object equality logic? A set ensures uniqueness using hash code and equal methods. When we add an object to a set, it first checks the object's hash code to decide where to store it. If another object with the same hash is found, it then uses equal methods to compare both objects. If equal methods returns true, it means elements are duplicate and then not added. If false, object is added. So the set does not know equality logic itself. It simply calls the object's own hash code and equal methods to decide. Okay. Next question is, does set allow null values? It basically depends on the type of set. Hash set and linked hash set both allow one null value, whereas tree set does not allow null value and it will throw an error. Okay. Why there is no get method in the set? There is no get method in the set because a set is not index based. A set stores unique elements, does not maintain position or indexes, focuses on is the element present or not. Since there is no fixed order or index, Java cannot return an element using something like get zero. Okay. How can we make a set thread safe? We could use collections.synchronize set to make a set thread safe. Very simple. Okay. Why is tree set slower than hash set? Tree set is slower than hash set because tree set maintains order and sorting. It makes more time to insert, delete, and search. Okay. Next question is, how does linked hash set maintain insertion order? So basically, linked hash set maintains insertion order by using a linked structure along with hashing. Let me tell you what happens internally. It works like a hash set. It uses hash code to store elements, but it also keeps a doubly linked list that connects elements in order they were added. Okay, so when we add elements, they are stored using hashing. At the same time, links are created between elements to remember the order. Okay, when we iterate over the linked hash set, it follows the linked list, so the elements comes out in the same order they were inserted. Okay, now moving to the next question, why does map not extend a collection? So I think we have already discussed this, but let me tell you in brief. Because map works differently. Collections store single values, but map store key value pairs. Their structure and methods are different, so map is kept separate. Okay, why are keys required to be unique but values are not? Keys are used to find data. If two keys were the same, Java wouldn't know which value to return. Values are just data, so duplicates are allowed. Okay. Next question is, why does map expose entry set instead of iterating directly? Map has basically two parts, key and value. Entry set gives both together as a pair, making it easy and efficient to loop and access both at the same time. Okay. Next question is, why are keys immutable recommended? If a key changes after being added, its hash code may change, then map cannot find it again and hence causing search and remove operations to fail. Okay. And the next question is, explain the internal working of HashMap. So guys, this is very important question. Listen carefully. A HashMap stores data in the form of key value pair, as we know, and uses a techniques called hashing to store and find data quickly. Okay, let's understand step by step. First is hashing of key. When we add data, Java takes the key and calls its hashcode method to generate a number. Second is bucket location. This number is used to decide which bucket in an internal array the data should go to. Okay. Third is storing the entry. The key and value are stored together as an object in that bucket. Fourth is handle collisions. If two key give the same bucket, they are stored in the linked list in the older Java. If many entries collide, it becomes a tree after Java 8 for faster search. Fifth is retrieval data. When we call get key, Java finds a bucket using hash code, then uses equal methods to find the exact key and returns a value. Okay. Next question is, what is default capacity and load factor of HashMap? Default capacity is basically 16. It means how many buckets the HashMap starts with. Default load factor is 0.75. It decides when HashMap should grow. This means when 75% of the buckets are filled, HashMap will resize. For example, if capacity is 16, so 75% of 16 is 12, and hence when we add the 13th entry, resizing happens. Okay. Moving to the next question, what happens internally when two keys have the same hash? This is called a collision. Both keys go to the same bucket. HashMap then uses equal methods to check and store them separately. Okay. What if equals method is true but hash code is different? This is very important question. So HashMap will treat them as a different keys and store both. Later searching may fail because it looks in a different bucket. This breaks basically HashMap behavior. Next question is, why does HashMap allows one null key? HashMap handles null specially and store it in a fixed bucket that is index 0. Since keys must be unique, only one null key is allowed. Okay. What happens if hash code changes after insertion? The object was stored using the old hash code. After change, HashMap looks in a new bucket and cannot find it. Search and remove operations will fail. Next question is, why should keys in HashMap be immutable? If a key changes, its hash code may change, right? Then HashMap loses track of its location and hence key must be immutable. Can you please explain the internal working of linked hash map? So basically, linked hash map works like a hash map plus linked list together. It stores the data as a key value pair like hash map, but it also keeps a doubly linked list to remember the order of the elements. Okay, let's understand this in a step by step manner. First step is hashing like a hash map. Keys hash code decide the bucket entry is stored in an internal array. Second is maintaining order along with sorting in a bucket. Linked hash map connects entries using doubly linked list. This list keeps track of insertion order or access order if configured. Third is retrieval. When we get a value, HashMap logic is used. When we get a value, HashMap logic is used. When we iterate, it follows the linked list to return the elements in order. Okay. Fourth is collision handling. It is same as HashMap, linked list entry inside the bucket. Okay. Next question is, how does linked hashmap maintain its access order? Linked hashmap keeps a doubly linked list of all the entries. When access order mode is enabled, every time you get or put a key, that entry is moved to the end of the list. So the list always shows most recently used at the end and least used at the start. Okay. Why is linked hashmap used for LRU cache implementation? LRU cache removes the item that was not used for the longest time. Here, let me tell you how linked hashmap helps because it already tracks access order. The least used item stays at the beginning. When cache is full, we simply remove the first entry, so it becomes easy to build an LRU cache. Okay. Next question is, why is linked hashmap slower than hashmap? Linked hashmap does everything hashmap does plus extra work, as we know, right? It maintains a linked list for order. It updates the links on every insert axis. This extra work makes a slightly slower than hashmap. Next question is, can you explain the internal working of TreeMap? So this is very important question. A tree map stores data as a key value pairs and keeps them sorted by keys. Internally, it uses a special tree structure called a red black tree. How it works step by step, let's understand. First step is sorted storage. When we add a key value pair, TreeMap compares a key with existing keys and places it in the correct sorted position. Second is red black tree structure. Entries are stored in the self-balancing trees. Each node has a key value, left child and right child. The tree automatically balances itself after insertion and deletion. Okay. Third step is searching. To find a value, TreeMap compares the key step by step in the tree and moves left or right until the key is found. Okay. Fourth step is no hashing used. Unlike HashMap, TreeMap does not use hash code. It uses compare to or comparator. Compare to for natural ordering and comparator for custom sorting. Okay. Why does TreeMap require natural ordering or comparator? TreeMap keeps keys sorted. To sort, it must compare keys, so it needs either natural ordering or a custom comparator. Without comparison, it cannot decide where to place keys in the tree. Okay, what happens if comparator logic is inconsistent? If comparison rule are wrong or inconsistent, keys may go to the wrong positions, searching may fail, duplicate keys may appear, TreeMap behavior becomes unpredictable. Okay. Next question is, why doesn't TreeMap allow null keys? TreeMap compare keys to sort them. If a key is null, it cannot be compared using compare to method or comparator. So Java throws an error. Okay. Next question is, how does TreeMap guarantee sorted order? TreeMap stores entries in a self-balancing tree, that is red black tree. Every time we add or remove data, it compares keys, places them in the correct position, rebalances the tree if needed. Okay. Next question is, what is hash table and why it is not recommended to use in our projects? Hash table is basically an old Java class used to store data as key value pairs. Similarly to HashMap, it was introduced before the modern collections classes and is thread safe by default. Okay. Let me tell you why it is not recommended. Because it was made in early Java, new classes like HashMap and concurrent hashmaps are better. Hash tables lock the entire map for every operation, so only one thread can use it at a time. It does not allow null keys or null values, which limits flexibility. We have better alternative exists like HashMap and concurrent HashMap. Okay. Can you explain the internal working of HashMap? Concurrent HashMap is a thread-safe version of a HashMap that allows multiple threads to read and write at the same time without locking the whole map. How it works internally: data stored like HashMap. It stores key values pairs in the bucket using hash code. Second is no full map locking. Unlike hash table or synchronized map, it does not lock the entire map. It locks only the small part where the updates happen. Third is reads are mostly lock free. Multiple threads can read data at the same time without waiting. Fourth is writes use fine grained locking. When a thread updates, only that bucket is locked. Other threads can still work on the other buckets. Okay. Fifth is collision handling. If multiple keys go to the same bucket, they get stored in the linked list and converted to tree if many entries like hashmap in Java. Okay. Sixth is resizing. When size grows, new bigger array is created, entries are redistributed and done carefully so threads don't break data. Next question is, why does it not throw concurrent modification exception? Concurrent hash map is designed for multiple threads. It allows safe changes while iterating, so it does not fail like normal collections. Iterations works on a snapshot like view, so no exception is thrown. Next question is, why doesn't allow null values or keys? Because in multi-threading, nulls can create confusion. For example, if get key returns nulls, we won't know key is not present or value is actually null, so it will avoid ambiguity. Next question is, how it is different from collection.synchronize map. Basically, synchronized map locks the entire map, whereas concurrent hash map locks only a small part, that is called bucket. Concurrent hash map allows multiple threads to work together and is faster. Next question is, why was concurrent hash map introduced when collections dot synchronized map exists? Synchronized map is slow when many threads are working because only one thread can access at a time. Okay, whereas concurrent hash map allows parallel access and better performance. Moving ahead, what happens if two threads update the same key? Only one threads update at a time for that key, that is internal locking. The second thread waits and then updates safely. Okay. Next question is, what is copy on write array list and explain its use cases? Copy on write array list is a thread safe list where every time we add, remove, or update an element, it creates a new copy of the list and makes changes in that copy. Okay, let me tell you the use case. When read happens a lot and writes happens very rarely. Examples: configuration data, listener list, cache readers. Okay. Next question is, why does copy on write array list allow safe iterations? Because iteration happens on the old copy of the list. Even if another thread changes the list, the iterator still uses the previous version, so it stays safe. Okay. How does it avoid concurrent modification exception? Since it works on a separate copy during iteration, the original list changes do not affect the iterator, so no exception is thrown. Okay. Next question is, can you tell me the difference between copy on write array list collection and collection dot synchronized list, when it is better than collections dot synchronized list? In copy on write array list, it creates a new copy on every write. Reads are very fast, goods when read are more and writes are less. Whereas in collections dot synchronized list, it locks the entire list. Reads and writes both require locking, slower when many threads read data. Okay. Next question is, when is copy on write array list better? When many threads are reading data, when updates are rare, when safe iterations without locking is needed. Okay. Next question is, can you tell me the difference between comparator and comparable? In comparable, sorting logic is written inside the class, only one default sorting allowed, whereas in comparator, sorting logic is written outside the class, multiple sorting always possible. Okay. Next question is, can a class implement multiple comparators? A class can implement only one comparable, but we can create many comparable classes for different sorting styles by name, age, salary, etc. Okay. Next question is, can you please explain the priority queue, DQ, array DQ, vector, stack, and their use cases? So first is priority queue, a queue where elements are processed based on the priority, not order of insertion. Use cases are task scheduling, job processing, shortest path algorithms. Okay. Now let's see DQ. We can add, remove elements from both ends, front and back. Use cases are sliding window problem, caching, implementing stack plus queue together. Okay. Third is array DQ, an implementation of DQ using an array, faster than stack and linked list for most cases. Use cases are stack operations, queue operations, and real-time processing. Fifth is vector, an old thread safe list where every operation is synchronized. Use cases are legacy systems, older applications, rarely used now. Okay. And the last one is stack. It follows the LIFO, last in first out rule. Last added item is removed first. Basically, use cases are undo operations, browser history, functions called tracking. Okay. Next question is, can you replace vector with collections or synchronized list everywhere? Mostly yes, synchronized list is modern and preferred, but vector has some legacy methods, not always a direct replacement. Why does synchronization not automatically make vectors safer? Vector locks every methods, but compound operations are still unsafe. Iteration still needs manual synchronization, so synchronization alone doesn't guarantee full safety. Okay. Next question is, can you tell me the difference between fails fast and fail safe iterators? Fail fast throws concurrent modification exceptions if collection changes during iteration. Examples are array list hashmap, whereas fail safe works on a copy, no exception. Examples are copy on write array list, concurrent hashmap. Now guys, you could pause the video and take the screenshot. These are very important and most asked scenario based question. So guys, this is all about collection framework, interview question and answer. If you find this video helpful, please don't forget to subscribe. Thank you so much. Bye bye.